Okay, welcome back. Applied ML for Social Good. Today, I'll be first reviewing a little bit of what we covered in the last class, and then going over more on the social good side rather than more on the ML side. But primary review of the process that we discussed towards the end of last class is when we are thinking about applying ML to social good, right? What is an easier way to actually break down that process and make it more practical? We discussed that it was identification, definition, solution, and deployment. The identification is an important part where being a computer scientist or being an engineer, it's not really easy to look at what's the white space. How do you create like reasonable problems that can be easy to define problems from such a large space of societal challenges, right? So that's one of the important parts where we need important stakeholders in the place, and that's understanding the social good aspect to the core, right? Definition is the part where we can bring in our expertise and bring in the knowledge of different computer science modules, things from machine learning and AI, and try to define sort of a question which is well framed to be solvable, or at least something where you can solve some pieces of it, or basically add solution to certain tasks. So that's the definition. And then solution is the biggest component as an engineer, where you would be building the entire pipeline of this is how I define a solution, this is how I obtain data around my problem. I describe the learning algorithms, I describe the process to train them, process to evaluate them, and actually build up something which is trained, which produces results that are usable results. And then we move it to deployment, where you deliver those results to the users and the stakeholders, finally passing the result of that learned process, all the solution, how to really deliver it back to the people who need it, right? So before we move more forward, so today we will be covering identification particularly and how it touches definition. And next week onwards, we'll go more over machine learning when we'll figure out different ways to define solutions. And later in the course, it will be deployment. Before I go further into identification, are there any questions around the process? Okay. So from last class, identification was defined as a space that societal challenges can span across, like there's a very wide space of domains. So we can have environment as one, education as another, healthcare, right? So the space overall is really big, and we need to find a problem over there which maybe we can solve. So identifying that primary component, identifying a target is really important, right? And then each challenge that we figure out can be broken down into several small problems. That is what you work towards. You can try to solve it, and then the impact that it can cause can often be significant, right? So focusing on the domains of social good, when we will talk about building the solutions, right? We need a very clear definition of what are the domains in which we are acting. Now, social good domains, as I said, like there's a wide and open space across several domains, and it's not really easy to just identify a problem which you can claim to be a very important problem. Maybe at times we are we can understand that, yes, as we were discussing last time, like misinformation is a problem that we understand because we observe it in our real lives, and we are at the receiving end of it, and we also are at an end where, I mean, we are being in computer science can figure out certain solutions directly, right? They're more related to that space, but social good space is really big, and we might not know anything about some of those domains. So it's good to have experts and the real stakeholders define them in certain way, right? We cannot just, I mean, we can define some local problems and some challenges, but if we have clear definition, that helps. And thankfully, because of United Nations, several countries actually got together and developed this set of goals, which are 17 goals called the Global Goals for Sustainable Development. In 2015, leaders from around the world actually got together in order to define them. So there are 17 very specific goals, and each goal has associated targets. Now those targets are sort of roadmaps to anyone who wants to improve the world in different ways, right? How can they use very specific objectives to go forward? So each and every goal comes with targets, and they are available at the particular site, and we'll actually be looking at them in detail. So these are the global goals, 17 specific goals. We may not cover each of them in detail, but what I really want to focus today's class on is a discussion around these particular goals. So going forward, we will map them to AI, right, and machine learning, how machine learning can be used to basically target different problems within these goals. But these goals will act as the primary framework for us, where we have very good definitions defined by people who really work in the space, like people at UN, leaders in the space, leaders in the fields. And then we look at the targets specifically, right? So I'll actually go to the goal site and look at these goals specifically. So if you go to this particular site, you can see that they have these details around each and every goal. And if we go to any goal, let's say good health and well-being, each goal has certain actions that are being taken place, but each goal has targets. And targets are what we will primarily focus on. So suppose in global health, good health and well-being, these are the targets: reduce maternal mortality, end all preventable deaths under 5 years of age. These are problems that have been identified based on large numbers of statistics, because people have evaluated, like across countries, this has been evaluated, what's the mortality rate, and then the problems were identified, and now organizations of each and every size are actually making efforts to fix these. So even the Gates Foundation, in the Gates Foundation, when they open up their challenges they have challenges every once in a while where they are announcing a large piece of funding, and they invite proposals and ideas to work on those. Most of them are targeting one of these goals because these are good definitions. If you have these definitions centered over somewhere, it's easier to basically approach the problem and then start building solutions. So some of these are in health, like fight communicable diseases, mortality from non-communicable diseases. And if we go into each and every goal, we will see that there's a good list of targets. Now, what I want to explain over here is that when we are thinking of a solution, right, coming in from a machine learning background, when you will look at a solution, you will have certain tools in your hand. You will have the capabilities of machine learning that you know can be deployed, but you don't really know how to define your problem within that capability space. Right? You want to center down all the information. So looking at these targets, that's how we can easily move. So what I want to do today is like cover some of these targets and just have a general discussion around, like, if anyone has some opinion on any of these targets, maybe we can discuss that. And primarily looking at a target, can you think of a computer science solution? It doesn't have to be ML from the beginning, and we can then think whether any prediction model can really help into it, or any kind of detection can help. But just look at a goal, look at a target, and see if you can think of a certain kind of computer science approach to target it. So I'll probably start with the poverty goal. And if you look at the targets, the biggest target is eradicate extreme poverty, which is a very wide scale thing, right? There are several countries around the world where the basic pay is way below anyone would be able to understand in different parts of the world, right? So, I mean, if you look at the definition of poverty, we want to reduce the number of people living on less than $1.25 a day. That, I mean, that is a really, really small amount. And yeah, in countries around the world, this is the reality. Like, there are several people who are not able to earn up to this much amount of money a day, right?
Yeah, but wait a second. What is that if it's, you know how like $10,000 in Florida, it's 5,000 maybe here.
Right.
What is that in terms of US dollars? Or is it in terms of US dollars?
This is US
the
dollars.
same as somebody here earning $1.25. So no housing, not even one meal, not even no shelter.
There's usually something called purchasing power parity. So these are typically normalized. I don't know if it is in this case. So the first thing you do is just exchange rate, but then that doesn't get what you're talking about.
Right.
So purchasing power parity is supposed to get at this. So usually when they give these numbers, it's normalized that way. And there are plenty of people who are subsistence farmers. So like to say they have no housing, like no, I mean they have like a dirt hut with a thatched roof, right? And then they farm for the food that they want,
But it's not that
right?
they're paying rent.
It's not that they're paying rent with $1.25. Like typically people in this condition are living in a place where they're not actually cash economy, right? So this is a conversion into the
Right.
local cash economy, but they're living in a farmer and that's the way they're doing.
Similarly, there's another way, reduce poverty by at least 50%. This is more on a global scale that you have larger numbers and you want to at least come to a substantial rate. Like by 2030, maybe the target that we set in 2030 would be on a much better quality of life, right? So, is there any particular thing which you can pick up and start to think about solutions? Otherwise, I can also like lead into a discussion, but I mean, if anyone has some instant thoughts, let's start that way. So what we are doing here is, these are some global goals defined by United Nations, and 17 specific goals, and each goal has a list of targets. That these are the social problems that have been identified, and these are certain targets that we want to achieve by 2030 to improve the quality of life all around the world. Now, what we are trying to do is looking at these targets, and if any kind of approach from a computer science background comes in, right? Let's say, actually, let me start with an example. So, to mobilize resources to implement policies to end poverty, right? Now, this there's a big space of policies, right? How do you actually get the voice of common people into the policy making process? In several countries, like in US, it's still done in a much cleaner way, and basically people are at a much better position to express their opinion when a policy is being developed. They have the ability to vote on certain points around it, but in several parts of the world, that's not the case. And a policy gets created, it's going to affect lives of many people, but their understanding of what it's going to do can be close to negligible. And it's just going to result into them being impacted by a certain policy and not associated directly at all, right? So just looking at policy making process in general, with the amount of technology that exists right now, and with the access of technology to people of different economic levels, is there any kind of visibility that we can increase in policy development process? Can you think of any solution around that? So there are policymakers, right, who are developing certain policies. When they do that process, they have to develop public policies. They have to look at statistics of the local, of the concerned region, and they have to talk to different people, and then they propose something, and then it goes into a cycle of decision, and then it gets implemented, right? So one thing is at the stage of developing that policy, when they are making the proposal, how much is the crowd really involved in it? Can the voice of the crowd be increased and be presented in a useful enough manner? I mean, if you just ask for opinions, like if you ask everyone individually for their opinion and you don't have any good way of aggregating that together, maybe you cannot really raise a strong enough point ever in the policy making process, because you don't have any centered discussion which is coming in and giving in the direction of how to actually affect the policy. But if you have a platform where people are collaborating in small groups, those collaborations are resulting into some highlights, and then people are looking over that, and there's a naturally evolving hierarchical structure which sort of ends up into more concrete points being established with at least like some commentary from everyone or some voting mechanism from everyone, and leading up to a state where you have a large number of policy points, public policy points, developed collaboratively by a large number of people who are going to be the stakeholders when it gets implemented. So that's a solution that technology can provide. And one similar solution was actually even tried in Europe. So that's just one approach around policy, how computer science can come in and start to affect things. It's all two hands.
I can talk.
Okay, and you have?
Okay, so wait, let me make sure that I'm understanding the question. When I'm looking at this, I'm thinking about a couple of things. One, you want everybody's voices to be heard so that the policy really reflect what's good for people and not just a handful of people that have it here making policies.
Yeah.
But in order to do that, you need, in my opinion, I could be wrong, two things. One, you need an informed populace that understands the policies and the ramifications of them.
Yeah.
And two, you need to have ways where that populace can vote easily and register their opinion easily. And one of the things I'm thinking right now, I mean, I know that you think in America we don't have these problems, but obviously we do. I'm getting a lot of chatter on Facebook that in Maryland with the new license plates that you have to have, I mean, the new driver's license that you have to have in order to fly, and how they have to be validated, they can't just be normal driver's license. Otherwise, you can't just fly with them. After, what is it, October 2020? Does anybody know? You need to have your passport to fly if you're from California or some of the other states where the driver's licenses aren't vetted. And in Maryland, all new driver's licenses are vetted and they have to replace them all out. And there's a big problem right now because people born before, and I think it's like 1960 even, the birth certificates are being rejected by DMV. Because, I mean, even the original birth certificates that people had to get their passports, they're going to DMV and DMV's like, that's not a valid birth certificate. And so all of these old people, like, literally, you can sit there in DMV and person after person after person being rejected for a license, driver's license because they say your birth certificate is not a valid form of identification. So, I mean, that's going to be a barrier to voting for that whole block, right? So I mean, that's one thing too that maybe we could tackle.
Well, I think I think every time you try to tackle something, if any of us proposes any solution, I think immediately you're going to get 10 problems like that are going to come, right? Okay. So like you're proposing a solution where I'm going to have a relatively uneducated population propose policies that's going to help them. It's not immediately obvious to me that they're going to propose policies that help them. So I think every time you have a populist political leader, they propose non-ideal policy, right? That gets you Brexit, right? Like that's not actually good for the people that voted for it, right? Like, so, but the population thinks it's good, right? So like, okay, well, but that's a criticism of that way. So like, I think designing something that really works is another thing. So I think one step in the process is to design your rules like this. There's a whole other step of saying like, if you could change this metric, we believe that would actually be the right thing to do, right? It's broken to an even lower level where you can get to it, and frequently these kind of lists don't, right? Like they have the, like, we're going to eradicate poverty, but like, okay. You have no math, like, I got a lot of approaches. When am I going to do that through job creation? Am I going to do that through social services? Am I going to do that, right? Like there's a lot of ways you can go about that. And I think getting people to agree on that.
Just say it. I think I love sitting around coming up with, okay, when I say sit around, I should cut that. So I love coming up with creative ways to solve big problems. Like things like how to fix poverty. Like, well, we all know the chances of somebody in this class fixing poverty as their class project are like not large. At the same time, we are at a university that has lots of, and often these problems are hard to even, you don't know how to approach them. You got to be creative, come up with some solution, even if you're very creative. People have been trying to be creative about this for a long time. On the other hand, we have entire departments devoted to things like ecology, which generally the entire department is working on things which are basically fit into this list. The people there have spent their careers, figuring out what the problems are and figuring out ways that they can help. And a lot of them, I know at least a few examples are in need of people who have machine learning skills in order to solve these problems, right? We can do a lot today that we couldn't do even a few years ago. So maybe, so I'm actually, it's actually kind of, and to bring this in, we have all these job fairs where they bring in all of these companies to talk about the problems that they want students to work on. Right. I haven't seen this yet happen for actually inside the school, just having like people from ecology and sociology come and present problems that they think the machine learning people could help them out on.
Right.
That could probably actually do a lot of good and provide a lot of masters and dissertation projects.
Yeah, that might be possible. I mean, it obviously has to depend, like a student cannot really just decide to work on any space because the student is still learning, right? If we have faculty level collaborations, that is much more practical because now the ecology faculty, the Department of Ecology can basically bring in that expertise and but a student going in, learning how to implement ML for different spaces, right? Or maybe having certain knowledge in that might not be the best person to just take on a big challenge. But yes, if that collaboration can be built, it would be great. But from a student point of view, that might not be an easy step to just take as the first step. Our hope is that a larger consensus will, like organizations which are actually investing into this, right? Like I said, Google was doing AI for social good now, and McKinsey is also getting involved. They have the skills and the capabilities to actually bring in real experts in the field. But learning how to do this is still it's still a learning process. So it would be great if the department can propose and students can actually collaborate into it. But expecting the student to be the expert might not be the right way.
I think the general point that there's experts on campus who phrase it in a way that other academics can understand, like that's good, right? Like this is the big messy real world, right? So like I think this general idea is there's fruitful collaborations to be had there. So going on right now on campus, some of the people in astronomy and some other places are trying to put together an AI institute, something where they basically have big data problems they want to solve with AI, right? And there's some contention surrounding it because computer science is like, hey, we're the AI experts. Like, why are you having the institute? So like, but okay. Besides the turf war, it is true that the other departments on campus have problems they want to solve. They have big chunks of data. Like, I mean, you think about what do the bioinformatic people do? Get terabytes of data on genes, something that I don't know, it's good for medical something, right? And if you can, right, like I'm not an expert in that, right? But if you run your ML on that, which is essentially what they do all day, then like you get medical findings, which is useful, right? So this is certainly true that on campus there's those resources, but I think his point about how to structure it so that it works well makes sense, right? Right. So like if I take a senior PhD student, they're probably in a position to go do this. If I take a first year master's student and say like, go help with the ecology guys, I think the chances of solving their problems is not so high, right? So, but I think there's room, and that's an interesting way if you think about like how classes like this can run. Yeah, like that's an interesting source of problems to work on.
Yeah, I agree 100% with that. I gotta say, and it's really interesting to hear what you said about the physics department is starting an AI institute.
Research. Yeah. I think if you search UCSC AI, you now get astronomy.
Yeah, astrophysics.
Right. Santa Cruz Artificial Intelligence Club, AAII. I think this thing is the lead guy doing this thing.
That's like the Wednesday meetings, right?
I don't know. I think this is out of astronomy, right? So.
Well, yeah, there's a Santa Cruz ML, and that's recently merged with this thing they were calling AAII, which I'd never heard of. And they're just like weekly meetings on Wednesdays, which are totally done. They're either in E2, yet still it's almost all astrophysics and genetics people. I don't know.
So I don't know who's involved. I know that the CS faculty are not yet strongly involved with this, but that doesn't mean it's not something really useful. Right? So there's smart people all over campus, right? I don't know what they're doing, right? And so if anybody in this class goes through and goes, I know what they're doing, I want to know.
I mean, it seems like
what do they do?
They call it by the way, the Santa Cruz Machine Learning Cooperative.
Okay.
And I learned there this concept of application dating, which is exactly what you're talking about, getting people that have the data together with people that have the machine learning skills. So application dating is what they call it. So they're trying to do that a bit in that group. So,
Right, because it's, I think, started by the people who have the applications, and they're like, dang, we better start this thing, and we're gonna get some people to come help us, right? So I think that's an example of this happening. So it's not well organized, right? So like you're saying, oh, I need to see it faculty, well, currently, you know, not really, but I think also when you're trying to apply problems, CS faculty are frequently going to be interested in how do I have next year's ML algorithm, right? Like that's the research that they want to do. If I'm the ecology guy, I want the ML algorithm from 10 years ago. I just want to use it, right? Like I don't need to be the newest, latest, whatever. Like I need to have some knowledge about it, right? So I think that there's different needs.
Yeah.
So basically, your comment just backed up what James Davis said on Tuesday and what Ratchet said, where we need to get specific info from experts in that area that we then help them tackle those problems. So, I mean, because like, what do we really know about some of these areas? One thing it made me think of though, and this is sort of an aside, is I went to SIGSE, which is the
CSC.
special interest group for people that are interested in STEM education, right? And they had this speaker on the very last day, nobody was there, it was amazing. I think she was from Singapore, and what they do is they make their students do a social good project. And it takes, I think, 2 semesters, and they implement it in the summers. And so one of the projects they did was they went to, I want to think Indonesia or Malaysia or something, a country that tends to have like a monsoon season. And in a like really poor town, and the parents were all concerned about their children falling behind and not using technology, so they wanted a computer school. So one of the visits was, where are you going to put the school? And going there in the room that they would give us for the computer school floods every year. So that doesn't work with technology. And so the class came up with a really cool idea of retrofitting buses to be mobile computer schools. And then they took donated computer parts and they made suitcase computers that were easily portable. And they went there, they installed it, and they taught people, and then they went back a few years later to see, like, is this rusting somewhere? Are they all using it? And they were all still using it. So they were actually able to implement something that changed people's lives, right? And but they do a lot of projects like that, and it's a requirement for graduation. And I thought, wow, that'd be great. I talked to Hempel about it once. He was like, yeah, no.
Similar. Who all knows like Raspberry Pi, the small chipset? Right? So Raspberry Pi is a very small embedded computing device, which is like this big, and it has a processor or multi-core processor. You can run Linux on top of it. There's a version of Windows also which you can run on top of it, and it's basically a very tiny computer. When it was launched, it used to have right now you can buy a Raspberry Pi and it will have the video out as an HDMI. But the initial one had a TV out, and the primary use for Raspberry Pi was in the space that places where people don't really have computers in developing countries, right? Very remote locations. This is your computer, tiny computer, connected to a regular TV, because TV was still like widely available almost everywhere. So connect it to a TV, and then the peripherals like mouse and keyboard can already be connected, but it's a small computing device. And you can start developing applications that start providing access to the internet. And this was like a really small thing, but with a perspective of social good, started out actually, and I think in Africa in several parts, it was widely used. And then it actually led on to more similar devices on top of Raspberry Pi, which means that Raspberry Pi is your base, right? Initially started as just a computer, just a replacement for a computer, a low-cost computer, then became actually an embedded device. And again, an embedded device, which means you can build something like a small robotic kind of thing, and the application space in social good is wide. So they are being used in farms. You can basically use it to develop a small tool which can help farmers in different ways, like detecting weeds. And several applications in social good just from that small device. So that was again one piece of research which was I mean, it's taking in computer science, right? Just boiling down to a very smaller computer instead of a larger computer, and once it gets into the process, you start seeing returns, and then it starts evolving itself in the social good domain. So that's another reason why going in with any idea into social good can be helpful, because even though it wasn't the perfect approach at the beginning, when real people get involved, when they start using it, they might be able to improve it drastically. And Raspberry Pi is one of those examples. It also grew in the embedded space widely, so it's used all around. But social good was one primary application area as well in the beginning.
Go ahead, sorry.
There was also something called OLPC. I don't know where that project is right now. Do you remember?
More
One laptop per
child.
child.
Yeah, do you remember
The what?
one laptop per child? This was in MIT Media thing, right? Okay. So this was, I was going to make a point surrounding this, right? So when you think about your projects, like one laptop per child makes my point very nicely, right? So I had some academics that said, like, we can build a computer that's going to be under $100. So Raspberry Pi we now have, but 15 years ago, it was less obvious you can have something like this, right? When it got manufacturers, when it got people on board, when it talked to ministries of education, like, we're going to ship these things, they essentially got stuck on how do you get to the end of your process? Like, they can manufacture those, right? They got open source teams to build new OSs and like do all kinds of technology got done, and they're pretty awesome little machines. Now, well, I'm gonna have the poor people buy them? No, I have to distribute them. How am I gonna distribute them to millions of people? Oh, well, that's a problem. Maybe we'll use the Ministry of Education. Oh, well, now they have to approve it. Well, now they have to have a budget. Now, shall they use their budget on teachers, or shall they use them on these computers, right? Like, I've got poor villages where people make $5 a day. Like, would I rather get a teacher, or would I rather get a make your choice, right? And the claim of the technologist was like, you don't need teachers, like, they're gonna learn themselves, just give them the internet, right? Which turned out to be not true. Yeah. Right, like, that doesn't work. Like, you need teachers to know if you want people to learn things. So that's a project which kind of sort of fizzled and died because they couldn't really get it. So India famously rejected it. India said, like, no, we don't think it's the right budget choice. Some other countries did it. They were shipped, they were used. It's not like they were never used, but it sort of didn't explode the right way from, like, putting it out there, right? And, like, so where did the real $100 laptop come, right? Well, market forces caused netbooks to be there, right? So this is maybe a little bit before you're thinking, but we went from laptops to little tiny things, right? So now we would have tablets, you would have your smartphones, you would have your other kinds of things. We got Raspberry Pi, which was driven not so much by the developing world need, but by the hobbyist need, right? Like, in order to build stuff like that. So the market forces cause what can actually be there. So when you think about your social goods, if your idea is ever, I'm gonna make this thing and, like, get it to 1 million people, your distribution problem is huge. You may have an idea that's gonna, like, make all the farmers 5 times as efficient. How are you gonna get it to them, right? They're distributed all over the world. Like, I need it, like, I'm gonna build the world's biggest distribution network in order to do any Walmart, right? I can't, like, how are we gonna get it to this, right? So those turn out to be really hard projects, and you always have to ask, where's the money coming? And, like, now you better get some business classes to solve that piece. I feel like there's a lot of leverage for us as engineers. So I'm excited that Roxy's doing this class. There's people who have to make decisions. They have a big ton of data, and right now they make their decisions not optimally. And you can make their decision-making 5% more efficient. And that makes their service provision 5% more efficient. And they're already dealing with, if they're selling products or providing services or whatever they're doing, like, your role is, like, you already have to make a choice. Let me just help you make the right choice. And then there's a 5% win. And then you don't have the 10-year problem of, like OPC, like, what's happening now? Well, like, they're not doing it anymore, right? But, like, if you make a framework that people can make choices, somehow your cost in is easy, and, like, you just give them your system that makes the choices, right? And you don't have to deal with the rest of the problem. So I feel like it's a leverage point for us. So I think that that's somehow much easier than, like, I have this new widget from the people. Like, that's the history is full of that not working. Even, like, you're talking about the bus. So there was a lot of projects. These were usually called the village computer, right? So you would go to a village, and then you, like, put the village computer there, and then everybody can come share it and get access to whatever they're doing. So these were popular 15, 20 years ago. And then everybody that did it said, like, we put it there, people love it. So you got dozens of papers on how it worked. But then you go look retrospective, like none of them are running obviously, right? Because like, what do people really want to do on computers? Well, it didn't exist. They want Facebook and like watch movies and like, and why were they put there? Oh, so you could access a doctor and you can get your government records. Like seriously, does anybody want their government records? No. Right? I mean, like it's a need, but like it's not the driving force. So most of these ended up not working in retrospective studies. So I don't know the particular one you were talking about, but like that's an example of lots of things done like that. Analysis 10 years after them being done failed. So that's not unusual to have these kinds of things. So as you read about technology, social good things, you should always be wondering the follow-up, right?
Yeah.
So as we think about projects, right, like I think that one of the nice things about data-only projects is that's your result. The data is the result, as long as you have somebody who wanted it. And hopefully that person is an educated person. You don't have the problems.
I think the bus was supposed to be like a training facility, and they had, like, either they had a trainer who asked for the computers,
Right.
or they trained somebody that could then, because it wasn't supposed to just be, I can go there and use the computers, it was supposed to be like a school that could move during the rain season versus being.
And this is always true. You always have to put somebody, all of these village computer things, so it is a divergent from this fact. And all of these village computer things, there was always like, because you have to think about sustainability. So there was always an idea, like you put it here, this guy runs it, we charge the villagers 1 penny per use, that guy gets to make $1 per day out of it, so there's an incentive to like know how it works and like keep the viruses off, but like you still have an overall cost structure problem. Like, okay, when I need a new one in 5 years, I can buy stuff on the computer, right? And like, so like there's a sustainability, right? So it depends on the exact scenario. Actually, I never heard of bus one, and I like it because you can move it around, right? As opposed to the village computer, which is in a remote place. So like maybe it has a better, I mean, not to get sidetracked on that particular thing, but I think like the Raspberry Pi is a similar thing. I can give you dozens of projects like OLPC, which were, we're gonna build a cheap computer for 4 people. Fail, 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 fail. What happened? The market caught up and provided $100, right? Like that's what actually.
Which is another thing, like when you're thinking of solutions from the computer science side, is that going in too dedicated to the particular application might not be the best approach in general, but in case of social good, it's even more prominent because you want to still have sort of a general view going in. Like if the idea is to solve a certain problem and the optimist objective is to really get it solved, a new problem might emerge out of it, but at least that particular portion will be fixed. So maybe going in more general with the approach is actually a better idea rather than thinking, okay, I have sort of like pinpointed each and every aspect in the problem while not really being a part of the not really knowing the problem yourself. You're looking at, maybe you do literature review, you do look at the statistics, but there's only so much of the problem that you can understand, right? So there is this line that you go going in with small steps, building in a solution, looking at certain data that you have, deriving some results from that. You can evaluate. You can evaluate maybe, so from the machine learning point of view, you look at a problem, any of these the policy problem, right? You look at the problem that you have certain statistics of people's satisfaction with a certain policy, right? Those can be derived. And then you run a small experiment at some place where maybe you don't actually implement the policy, but you just get opinions together and build a system around it, which will do summarization of content derived from different people. And then you have a layer of experts on top of it who are going to take that summarized response and build policies, right? Now evaluate the satisfaction on policies derived from that space. So it's still a smaller step. It's not 100% implementation. You're not saying, okay, this is done, and now if this system doesn't work, we will fix that problem later. You're going in with small steps, taking in pieces of technology and evaluating their result again and again. And that's why the solution phase is more of like that cyclic process, that data at a certain point in time can give you a good validation of what you're doing. But as time passes, you want to evaluate more and more, because particularly in ML problems, whenever the data set is time-centric, results can change drastically. A problem not in social good, let's say a problem is that you're working with data on sales of a certain kind of ticket, right? You're working with data set on ticket sales. Your job is to predict ticket sales, right? You take in different points, different input features. Okay, what is the interest of this person who buys, and combining different features from the data set, you predict at this point the sales would be so and so. Like that's how my sales would go, right? Now this, and then you evaluate it on your validation set. It gives great results. Did you miss anything in that process? Possibly, right? You had a certain limited set of features which were looking at the pieces of information of those particular people who were buying the tickets, maybe their other ticket purchasing patterns of the market at that point in time. But was there something special happening around the region in that on that particular point in time? Maybe it was like maybe the season was affecting it. Maybe it was summer and there were enough number of tourists in that particular region. So your data had a really different distribution and your prediction model worked and you covered it within, let's say, a 3-month period of time, and even your validation showed great results. But is it going to extend into the 4th month when all of a sudden life is very much different within that particular region because there's no summertime or no vacation time, let's say, everyone has moved out, and now the tickets are dependent on a different market statistic, right? So why I'm talking about this point is that evaluation in machine learning is highly sensitive to any choice within your feature space or within your data set. This is just one example on tickets, which will clearly show an impact. Like, let's say you have your like July, August, September, right? And then you look at the results in November. It's another holiday season is starting. It will have something different, totally. And if your data set to train these things was monthly, you cannot really incorporate the information about season efficiently anyway. So how do you deal with that? Maybe derive more data, maybe choose different metrics, maybe like put in more time variables. But these are problems that can emerge in ML very naturally just by incorrect selection of features.
Have we actually got over any positive examples of using data science for social good? I mean, where it was clearly a success that ended up getting to the target populace.
Mm-hmm.
Like we talked about the examples we were talking about just now were all kind of Village Virtual PC. These are things that didn't really pay out yet.
OLPC was the one that didn't work out. Raspberry Pi was the one that worked out.
Well, but Raspberry Pi is now evolved to include they're more used for people like us, right?
Which is how it started anyway.
So kind of diverge from that.
No, not diverge. It's just expanded. It's a wide project.
I mean,
it's used in social good.
He's arguing it. Oh, you're saying it is used in social good.
Yeah, it is used everywhere. I mean, its use in social good is not diminishing. It's just that it's used in anything else. It's just expanding usually. I mean, Raspberry Pi are used for so hobby projects was the one thing where they were obviously used, but now they're being used. One of the examples that I showed the last time, right? The TensorFlow belt, the cucumber sorting.
Right, we talked about. So did you look up whether this actually got put into production?
No, I haven't checked that one, but that's just one of the examples of someone really using it as a product, right? That's not someone giving it as a solution for a social good. What I'm saying is that its usage is widely, it's used almost in every domain right now. So not specific to social good. Never started specific to social good, but something which has expanded.
The question was, do we have any actual examples that are a success in social good?
There are several. I don't have any at the moment, but I can put them.
I'm sorry to put you on the spot with that question. I just realized that I don't know the answer to this question. I mean, it would be really cool that you can have a list of that. I mean, I know so many successful AI projects, yet I don't know any that really. I mean, and people often they present these things that are for social good, and they present them when they look good, when they're still in the.
Yeah, there is so there's the retinopathy one, which is another one from Google. So they had a large number of images of the retina scans, and which is for diabetes, detecting diabetes. That is hugely used. I think it's already in use by larger corporations. Similarly, in healthcare, actually, there are a larger number of applications, particularly AI use cases. The readings that I'll share today actually have better detail of that, so we can go over that.
Okay, cool. I'm interested if there's some patterns on things that succeed in this domain versus things that don't.
I mean, there might be, but I don't rely on patterns. I mean, it's good if patterns can emerge, but these are things affected by multiple factors. Patterns within a very basic set of problem, small feature space problem, are still easier to observe, but when we are talking about AI for social good, the space is really wide. And in terms of image, because the AI for classification in images is really good, like the state of the art is really well performing. Any application related to that segment is still better right now. I mean, in text also we have reached, like in translation, AI has also reached to a very high level. But there are several spaces where you still don't have enough ML success to result into huge success in just varied application domains. So those are some factors which will affect how you see results. But anything related to image, if you can boil down those problems, like disease identification in plants, right? Looking at the images.
Okay, but that is if you're going to make that argument that, okay, you can do this kind of research and then that leads to, the advancement of technology leads to all sorts of good happening. I agree, but then you have to take the bad with it also. It is also at that exact same moment, when those classifiers started working in 2012, that we started saying, oh, neural networks work now. And then AI became a concern. We started talking about the end of humanity, whether that's a serious, risk. I mean,
that's just a different point.
Oh, no, because really there's a lot of negatives that come with AI also, and the advancement of technology also.
With anything.
So I don't know if it's fair to just say, okay, if we're talking about AI for social good, why not talk about things that are clearly for social good as opposed to just, I can justify my research by saying it has, possible applications.
I think that's fair. So I think an interesting thing to do in class will be, and you may have these meetings prepped already, like, so, it's another places have had tracks on AI social good, right? Or you can pull from AC data for Compass, or, like wherever, from some kind of place. There should be readings in this class that are examples of there was a social good, and if you pre-screen those for it's actually working, right? Like, or at least can label, like, this was one that was a paper but didn't work out, this was one that was good, like, it's actually being used, right? And I think that's, like, those kind of anecdotal examples would be great to get out of this class.
Yeah.
So you may not have a preference in today's discussion, but I think I'm especially doing a lot of negative of, like, that doesn't work, and, like, that's because I think, like everything in life, 90% of ideas are not good ones, right? Only 10% of ideas are good ones. So all of our first ideas are likely down pathways that other people have tried out and didn't necessarily pan out. And the ones that did pan out, we now take for granted. So we don't, right? And we don't think of it that way anymore, right? So I think, but we can easily,
I will basically,
right?
I have the list prepared. So
I'll start putting the conferences about people doing this kind of thing. So I think we can have those, right? Yeah. And that will aid that side of the discussion of what doesn't work. So I don't know when you have a plan in the course, but like it seems like there's a need.
I'll put them.
Okay, I might be shown. I probably should. I'm not having an email class, but I did do a women in data science talk at Stanford last year, and there was a woman that used to work with the Obama administration that now is back at Harvard, and she was really great. In her talk, she talked about a reporter came to talk to her, and he didn't want to talk about all the great things she'd done in her career. He wanted to know about her arrest record, and she was like, what are you talking about? He's like, yeah, tell me when you were arrested. She's like, I've never been arrested. He's like, but I saw it on the internet. And then, so they opened it up, and they did a search on her name, and it came up, and it said, pay this money to see this person's arrest record. And they paid the money, and it was like, oh, arrest record is empty. And she was like, gosh, why is that even there? And he goes, oh, it's probably because you have a black name. And she was like, I don't have a black name. And he's like, yeah, you do. And her name, I think her name is Latanya or something. And he goes, yeah, because they looked up Tanya, and that little block doesn't come up. But if you were black or Hispanic, that block came up. And then she actually looked at the data, and she did this big thing. She found that systematically the search engine was, I guess, allowing advertisers to only put that block if you were Black or Hispanic, right? And it becomes a barrier to entry for a job and for an apartment. Because if I'm looking to hire somebody and I look up your name and it doesn't come up, but I look up, Sophie's name or, Sonia Mendez's name and it comes up, I'm not going to pay the money to find out the arrested thing is empty. Instead, I'm going to go, oh, been arrested. Okay, I don't want to take a risk. And that person's less likely to get a job with the department. So based on what she found, they actually changed the policy. And now they're not allowed to do these targeted ads like this on certain names, right? She also found, she might be somebody who really knew, but again, I don't know if this is informatics or machine learning, I don't really, because I don't know the difference. But another thing that she found that she talked about in her talk, which is super motivational for me, is they found out that GRE and SAT prep classes charge more for Asian families because they assume that Asian families are more invested in their children's success academically, so they actually charge more money for these courses. And now they're not allowed to do that either. So she actually changed policy when she was with the Obama administration with findings like this. And that affects a lot of people. And that is for the social good, in my opinion.
Yeah.
I love it.
So this is very much so. This is it's an interesting thing. So this one is probably. I mean, when you buy ads on search engines, you just say which keywords you want. So if nobody does anything, nobody can go say, I want the keywords that have these names, right? And like start whatever ads they want, right? You have to take an action to get that to stop. So that's probably nothing about some smart system. It's just like people chose it and nobody wanted, right? But I think you can easily design systems where it's not immediately clear that it's social good or not. So one of my other students was telling me that there are cities now which are making parole decisions this way. So you're
making what?
Parole decisions. So you're arrested, right? Like, okay, and it's some minor crime, right? You're in jail for this long, and now, like, after 2 months, are you allowed to get out early, or you got to stay there for 6 months? Now, so used to be you meet your parole officer, and they try to decide, and they try to guess, like, are you likely to be back here after doing something else, or like, it's okay, let's go, right? So now they stick AI systems. They stick all of this kind of thing on there, right? Now, is that a good thing or a bad thing? If I could accurately decide who's going to commit another crime, like that would be a win, right?
Yeah.
And that's what's being sold to cities, right?
Yeah.
But now, what if the truth of that accuracy is certain ethnicities are more likely because they're in different economic brackets or like whatever, right? And so now you're going to put that on everybody that matches into that set. Like, I'm not sure I want my society organized that way, right? So like now, right? What do you want your system to do? And I think this is a very normal thing that happens with AI systems. So suppose we built the perfect AI system and it gave perfect predictions. Would you? I'm not sure that's still the society I want, right? Like you may not actually want that answer, right? So I think this is something that does come up. So you give an example, which is a very simple one, but I think that like that comes up, and those systems are getting good, and people are starting.
Can you imagine? We're keeping you in jail longer.
Because some algorithm we don't understand.
Because you have a name that could be considered Hispanic. So we figure you're going to just commit crimes again. We'll just keep you.
Well, no, and it's much worse. No. The obvious things like this, like people will take out of the system, right? Like, because you try to build an unbiased system. But the thing is, you know the way AI systems work, right? I got a deep neural network. There's a bunch of stuff nobody has seen yet. Right? Like, the researcher in the world has no idea what's in there. Like, it does something. The predictions are 85% accurate. That's what we do.
Yeah.
And what is it using is the features. We don't always know. So how are we going to validate our system?
Here's the thing. How do they know? How do they know it's accurate? Maybe somebody who spends more time in jail and then later commits a crime. And you said, well, they stayed in jail longer because they were more likely to commit a crime, or so we thought. And then look, after we kept them in jail more time, they did commit a crime. Well, the more time they're in jail, the more removed they are from society, the more they lose the skills from society, the more they get indoctrinated maybe in the criminal world. So maybe it's easier for them to go that route than they wouldn't have if they were living their short time.
Yeah.
So there's a causality.
Human intelligence should not replace machine. Machine cannot replace human intelligence, or how you conceive things. A lot of these platforms are largely used in the United States, where bias is stereotypes have been the norm. And so it's more about, I mean, these things are great. You can have these platforms, but people, you'd have to change societal thinking in the United States in particular. It's not being used elsewhere because it's not the norm to think if someone is Hispanic or if someone looks Black, they belong to this section of society. You know, in other countries, people are able to either tell the difference or you're from Oxford, you're different. But, you know, a lot of this has to do with how America is built itself. So I don't think that we should not invent something because we feel people how they choose to use them, you know, becomes problematic. But that's something you have to teach. You either use the police for that to do that because they, you know, they have years of experience. But like he was saying, a lot of these things are doing societal good. When he said, you know, some of the platforms are able to detect disease, and it may not be something that's used by every one of us. You know, you are not worried about being a diabetic or HIV unless you get it. However, what has happened in medical technology, while these things started small, they're being able to detect different virions in different locations. HIV, for instance, and cancers are very different from, it's not just race, they're different from country to country. So it's very important to be able to really detect what it's doing. And that's what he means by, you know, and while the statistics may not have reached the larger population, these things are really impacting how medicines are even delivered to places like Africa, Asia, or underserved areas. So it's very important that we have these platforms because there'll always be people that use them for the right purpose. You know, it's good to be able to identify something or then identify images, facial images, but how we use them, just like the internet, you know, you can use Snapchat to people, some people will use it to, you know, to with horrific images, whether to children or anything. We as scientists, I don't think, can detect what people are into, but we should always have them. It's great to have my cell phone. If I'm lost, someone else is going to use that to hack, to, there's nothing you can do. It's something we can do, but maybe that's for the social scientists or the legal people, you know, to be concerned about. I, as someone that's got skin, can't go around, you know, worried all the time what someone's going to think. You know, it's just going to happen because I'm currently in a country where these issues have been there long before the internet, long before machine learning. My twin brother, however, who was not quite as identical to me by skin color because our mother is white, he was born white, doesn't have to worry about this. So it's just how are people going to think, you know, from country to country.
I think it's a good point that also a lot of these problems that we're talking about with why there's a need for AI interpretability, which I think your explanation is one of the best I've heard. That we have this need because when it comes down to certain things, you need to be able to see the rules plain and clear. Otherwise, there's going to be discrimination, which happens. At the same time, that discrimination which happens is often things that we already have in place in our society. But if we're to move forward as a society and decide that things like banks shouldn't decide on whether they can give you a loan based on, you know, what neighborhood you grew up in. Okay, so that might be good for them in terms of calculating risk, but it may be, you know, we might all agree that that's a bad idea. So at that point, we need to have algorithms which we can say that this is how the algorithm works. Yes, it considers this. No, it does not consider this. And that's why, you know, maybe this interpretability stuff, people are really onto something with it, that there really does need to be a method of enforcing interpretability on AI. How to do that, though, I have no idea.
So are you saying, so before we make something, think of all the ways it can be misused?
More like, so interpretability in AI is that neural nets, for example, right? They work, I mean, there is something that you can visualize out of it. You can see what are the features that are being affected more and the weights that are showing more significance in terms of generating results. But altogether, you cannot just see why you landed up to a certain answer with a certain kind of input data, right? Whereas there are some like basic ML models called decision trees and boosted trees, where this visualization is much more clear. Like you can basically see, okay, because of a certain kind of input, I end up into, this is the classification that I'm getting, right? I put in a certain record for loan and the result comes out. The reason for that result is more visible. So interpretability in AI is where you're trying to build this notion of recognizing why a deep learning model gave a certain result, trying to increase that. So at different levels, research is being conducted. It's fairly new field. Not much is out there, but there are certain models called distillation models. I think there's I may have read one paper around interpretability using distillation models, but that's a field which is trying to, because deep learning has shown the promise of really being useful, right? That has sort of been established. Yes, it can be useful. So we need these models. Now, what are the weaknesses of these models? They're not interpretable. They require a lot of compute resources, which is being fixed in different ways, but interpretability is one of those. And as that grows more and more, their acceptance in society would naturally increase, because now if it's giving a certain kind of response and I'm not liking it, but I don't know how to train it better, if I'm able to interpret that, I can maybe fix it, right?
Right. And so just quickly, no, not at all. That's not all what I'm suggesting. We'll never come up with all the things that could go wrong with it up front. What I'm suggesting is first of all, we just quickly. First of all, probably if you're looking for, if you want to decide upfront, what you want to decide upfront is what you really want a system to be optimized for, which might not be the easiest thing at first. Like if you're optimizing for the risk to the bank, no, that's not what we want to optimize for when we're determining whether we're going to get loans to these people. That's just, if you do it that way, we'll always end up with biases towards rich people are great to loan money to. Number two, so after you come up with some great thing, like I want this system to just benefit the people, however you code that up, I'm not sure. But once you come up with that great goal to optimize towards, then once you've got that system which optimizes toward that goal, if somebody comes up with a problem, like, does this actually bias against this sort of type of people, or is this, doing this? You need a way to answer that question and determine if the system does have that problem or not. Currently with AI, it's just really hard to answer that question on many models.
Just adding to what everyone's been talking about, there's actually a ProPublica article that covers the issue of like ML like just being used in like the judicial system in regards to like the recidivism rates that you've been talking about. And it actually presents like 2 case studies where it was used and like the results were faulty, like were really bad. I think it was like showcased an African American man that was like held longer, and the white man that was like released early, and then the white man went on to like commit some like really terrible crimes and ended up back in the system. So it's really good to like read and like highlight sort of the issues that have been going on, and then like these sort of systems, in addition to being used in like terms of like bank loans and stuff, are also being used now in like educational system to like rank teachers.
Right.
And so they like there are these models that will take in a bunch of information about like teachers, which is like scores like that students give them, right? But it also mostly uses like test scores on like standardized tests. And the idea, or like the idea that sounds good in theory is that you like rank the teachers and then like fire the bottom X%, and that way you only keep the best teachers. But in practice, it's turned out that like really good teachers that all the students love, parents love, they're loved by the community, end up getting fired just because their class might not perform as well on standardized tests. But that's not like really indicative of their quality in teaching stuff. There's a book called Weapons of Math Destruction that covers all the different models.
Yeah, different models, right. So there are several examples where basically AI is not at a perfect state. I mean, it's not even close to a perfect state. So just using it into any system and using that as the only mode, it's not a right move right now. But understanding how it's operating and trying to build that, going along with real people involved in the process, that's the hope. That's the hope that AI can be used more and more. Okay, at this point, I mean, if I'll put a 5-minute break so before moving into how we can map these goals to different capabilities of AI. The development goals, the global goals, I'll link them up in the readings. Basically, they are a good source to look at targets that have already been established by experts in the fields, and they act as helping points when you're looking into the process, right? So, I mean, at the class level, they are too big, but when you look at those, you understand what is it that, like, understanding the social good domain more, because most of us have a computer science background, and it's not the way in which we think all the time, right? So looking at those, personally, it has helped me figure out like more of the direction that I can take, and then corresponding to those, if we can think of smaller problems, if we can just look at problems around us, and because we have read those targets, it's easier to sort of make a map. What I'm going to move next into is this is so there's an excellent paper by McKinsey Global Institute. This paper talks about applying artificial intelligence for social good. So they have broken down the process into different specifics that I'll discuss in the next 3 slides, but they're trying to build 10 primary fields, which are going to be the application domains that you're saying that AI use cases. So given the current state of AI, what are the potential use cases, right? What are the real problems where we can apply AI? Then second thing you're doing is you're mapping those 10 use cases to these 17 goals that we discussed. So the 17 goals help, so in any kind of problem when you're starting, it's good to have certain sort of benchmarks or primary principle points, which help you sort of always stay connected to the real goal. That's how the 17 global goals are treated. And the 10 use cases that they have established, they first map them to the 17 goals, and then they talk about different AI capabilities. So things that we are already doing right now. Computer vision. Computer vision includes image classification, object detection, localization. So several things which have been established in machine learning research. People who are able to deploy those models. What are the social sites where they can which can use in that capability. Similarly, in natural language processing, you have text summarization, right? So in policy making, I was saying, just giving an example, that text summarization can be used. Similarly, in education, it can be used. Like you want to distribute lots and lots of information to several people around the world, and there are limitations at every space. But if you can use summarization tools, you can use translation tools, maybe information that is not easily accessible can be transmitted. So that's mapping, looking at the problem, because there is some understanding of the problem, you can map that. So how they look at it is, this is they have 10 particular use cases: crisis response, economic empowerment, education, environment, equality and inclusion, health and hunger, information, infrastructure, public and social sector, security and justice. Right, and the color is basically how much has already been done in the space. So health is particularly, health is at present the biggest use case of AI. Computer science in general, but AI also, there has been a lot of research in healthcare. There are companies where experts from ML and experts from like pharmaceuticals, I mean, you know, Insitro, like, has anyone heard of the name and the company Insitro? That's a company by Professor Daphne Koller, which is around drug discovery. And she is an ML expert, and she has a good background, I think, in environment as well. And this is where they're trying to bring ML to drug discovery. I don't have good detail about how they're using it, but that's at a very expert level. These interdisciplinary partnerships have already started. So how ML can be used in different spaces, right? So health is one of the biggest right now. Then for environment as well, a lot can be done. The crop, the disease detection example in crops, and these are wider spaces where, so in health, risk is very high with any incorrect thing. So in health, whenever something is applied, the precision is beyond, like, it has to be almost 100% precise, right? That's what you're looking at in most of the health use cases. Different use cases have different limitations. Like when you're distributing something, right? If you miss out, if your algorithm doesn't give an appropriate distribution of certain goods, let's say, and those lives are not dependent on that, the risk is not equally high, right? So the different domains have different levels, but these are good 10 basic areas. Crisis response is again very good, because and disease outbreak and disaster response. Disaster response is a space where any kind of computer science based tools are being heavily used. Facebook, for example, is really used whenever there is a disaster. People are communicating using Facebook, right? Trying to interact, trying to respond. Using such methods, identification of places with more need of resources, and then mapping them, like recommending the correct resources. Those are some small examples, small applications that are already being used. But this sort of gives you a direct application domain, which is really important. Things are already being done, but AI is there to sort of act as, so you had 10 people who were working on that thing, really helping everyone in the crisis situation. Now you have AI supporting them, right? Maybe any step that they take can be assisted with some more information, and that can lead on to better results. So evaluated over time, these things will prove more of their worth. But these are just small ways in which AI can start to add improvement. There's no point of replacing, like AI is not there to replace everything, but because there is this capability, which humans cannot look at thousands of data sets all together and just come up with a prediction, right? They are working on the process, but there is this ability to AI that we can provide, and that corresponds into results in several domains. So how these 10 goals, 10 use cases passed with the 17 goals. This paper will be attached in the readings today as well. Please do read it. We'll discuss it on Tuesday as well. It's going to be in the assigned readings also. But I think going forward, there are going to be more and more research papers. This is a discussion paper, but the way it's written, the way it has covered everything, it's sort of one of the best that I've seen so far. So those are the United Nations goals, the 17 goals that we discussed. And within these 10 use cases, what they're saying is that some use cases actually cover more than, many use cases cover more than one goals, and some goals use more than one cases. But overall, there is a good mapping that can be generated, which means that the important targets that have been identified at the global level and that are targets to improve the state of the world completely by 2030, there are AI use cases that we can map to those. So that gives us a good leading direction when we are talking about AI and social good. It gives us a good space of like the void where we can try to bring in solutions. How this maps with the AI capabilities is that over there we have at present whatever AI capabilities that we identify, like deep learning on structured data. Structured data means so tabular data, right? Or data which has which is not just varied. So images can be structured, cannot be, but data which has sort of an organized distribution, and on top of that you can pull up vertically, like you can pull up features vertically. I'll go over more details of the concepts later, but that's one space which is how typically deep learning is working. Like you have structured data sets and then you pull up features. And then natural language processing. So this goes into text summarization, understanding text, like semantic meaning extraction, sentiment analysis, and this is again a very wide space. Research, in terms of research results, natural language processing is one of the biggest areas of success right now. So in neural networks, there's a family called recurrent neural networks, which are the primary tool of natural language processing domain. And they have shown great results in translation, language models, which means like language models mean you're completing a sentence, right? So even in your everyday use, when you're using your keyboard on the phone, it's predicting the next words, right? That is one of the examples of deep learning in natural language processing. So similarly, there are more AI domains. What this graph is showing is how much they can be mapped to the particular 10 AI use cases, which are in your social good domain. Structured data and NLP are obviously, like, since texts can be associated with almost every domain, NLP is going to be important no matter what. Like there are good uses that you can get out of NLP and can apply into, for example, information verification and validation. That's the biggest space. Policy making, so when I was talking earlier about policy, it was more on the development side, right? Another side is that a policy has been implemented, right? And you want real evidence of whether it's working or not. That's the policy moderation side. Over there, you have reports coming out in public, you have media articles, you have responses of people on like commentary on Twitter, discussions around things. Using AI, you can actually collect that those pieces of information and derive certain meaning out of it, or derive certain understanding out of it. What is the response on a certain policy? If you want to just see whether it's effective or not, that can also be done with the help of AI. I mean, it would require experts to label certain situations of the data set, but following that, you can build up models. So, and once a model is built up, you can build, like, a well-trained model always leads on to more research in the space. Language translation can be heavily used in terms of education. The access of information and the access of educational resources is really varied all across the world, right? And in English, I mean, almost everything is available in English, but in various languages all around the world, people don't have access to good resources. If they want to stay informed, if they want to get educated around processes, language acts as a big barrier. Whereas if you have neural machine translation, like if you have the translation very well developed, very advanced enough, then that generation of translated text becomes, I mean, n times faster, like because now machine is translating it. You don't have any interpreter really translating all the documents. So that's a big change that AI can provide in terms of the development of the world. This is something where already, I mean, for few languages, neural machine translation models are working at human level performance. So, which is great. I mean, the model just translates language from one to other very quickly, and that's going to lead to a lot of success. Another, I think, is another important one is equality and inclusion, which is where you have the advantage in this is that data around the world, World Bank and many organizations around the world have been collecting data sets, have been creating large number of data sets on small things like distribution of electricity, like what is the availability of electricity in a certain region, right? What are the economics of a certain region? What are the average incomes? So a large number of different data sets concerning people in some way or the other are available. And several times it's easier to combine them. I mean, it's most of the times it's not, but so because there is so much information, you can combine that and try to derive certain interpretation out of it or certain inference out of it. If this particular region has had a certain level of income and certain level of poverty or certain level of malnutrition, right, can we combine those data sets? Can we build a prediction model on top of that and see that because of these particular factors, you can predict whether like these people will, the financial status of a certain region will improve within next few months, because there is, so data sets of this kind are available from like generally from 1980s. There are census data sets and there are large data sets available online. Most of them are available openly for free. So people can actually just draw certain small level inferences out of that, or build regression models just to see how things are working. And that may or may not lead to anything impactful, but it's a small step, and that combined with some other information can again lead to something impactful. So these are sort of entry points into really bringing in the power of anyone from AI and ML background or computer science background in general to start helping in social good domain, not solving problems completely, but making a difference. So yes, this is something you will find somewhere in the middle of the document once you start reading it. But what it says is it first describes the use cases, the 10 use cases, with certain examples of how they are being used. Then it maps them very well with the 17 global goals, which is a good way to understand that, yes, you're targeting the correct set of problems. And then it has a good discussion about using AI and how this thing can actually lead on to a great progress in the future. So we will be discussing it. So I think we're out of time for now, but any questions around all this? This is sort of the summary that we covered today. Any particular questions?